Hello everyone! Ever wished you could hit the save button on your PySpark data transformations, just like saving your progress in a video game? Get ready to unlock the magic of persistence in PySpark, your ticket to storing intermediate results and supercharging your big data analytics. Persist is a method used to persistently store a data frame or RDD in RAM memory or disk memory across operations to enhance performance by avoiding recomputation, typically employed when you need to repeatedly access the same dataset. Persist provides several predefined storage levels like memory only, memory and disk only, memory only serialized, memory and disk serialized. Let's deep dive into different storage levels provided by Persist in PySpark. Memory only. It stores data in memory as normal objects. Use this when you have enough memory to hold the data and want fast access. If data does not fit in memory, the excess partitions are recomputed each time they're needed. Best for iterative algorithms where you repeatedly access the data. Example: machine learning algorithms like k-means clustering. Memory and disk. It stores data in memory. If it doesn't fit, it spills over to disk. Use this when you have limited memory and want to avoid recomputing data that doesn't fit in memory. It provides a balance between speed and storage efficiency, suitable for large datasets that exceed memory capacity but need to be accessed multiple times. Example: data transformation processes in ETL pipelines. Disk only. It stores data only on disk. Use this when you have very limited memory or data that is too large to fit in memory and can afford slower access times. Good for very large datasets that don't fit in memory and are not frequently accessed. Example: historical data analysis where data is accessed less frequently. Memory only serialized. It stores data in memory as serialized objects. It uses less space but is slower to access because data must be deserialized. Use this when memory is limited and you want to store more data in memory, but are okay with the overhead of deserialization during access. Suitable for scenarios where memory is a constraint, but the cost of deserialization is acceptable. Example: caching intermediate results in complex data processing pipelines. Memory and disk serialized. It stores data as serialized objects in memory and spills over to disk if it doesn't fit. Use this when memory is limited and you need to store a lot of data, but still want a balance between memory usage and speed. Ideal for very large datasets where you need to maximize memory usage while still having the safety of disk overflow. Example: large-scale graph processing where data is accessed iteratively but can be large. Advantages of Persist in PySpark. Performance improvement. Persisting data avoids recomputation of expensive operations, thus improving the overall performance of the application. This is especially beneficial for iterative algorithms and repeated data access patterns. For example, in machine learning workflows, persisting training data can significantly speed up the training process by avoiding redundant data loading and transformation steps. Flexibility with storage levels. Persist provides flexibility to choose different storage levels based on the application's needs, balancing between memory usage and computation speed. For example, using memory and disk for large datasets that don't fit entirely in memory ensures that data is still available without recomputation. Disadvantages of Persist in PySpark. Resource consumption. Persisting data consumes additional memory and disk space, which can lead to resource contention and potentially degrade the performance of other tasks running on the same cluster. For example, persisting multiple large data frames simultaneously can exhaust the available memory, causing other tasks to fail or run slower due to resource contention. Management overhead. Managing persisted data requires careful planning and monitoring to ensure efficient use of resources. Data needs to be unpersisted when no longer needed to free up resources. For example, forgetting to unpersist data frames after their use can lead to memory leaks. As unnecessary data remains cached, consuming valuable resources and affecting overall system performance. I trust you found this video helpful. Thank you.